Hello, everyone. Thank you for tuning in today. My name is My-Linh Truong, the Division Manager for Unmanned Laser Scanning at RIEGL USA. We'll get started in just a few moments, but to set the stage for today's presentation topic, I'm curious to know, how long do you think that it should take from start to finish to set, collect, and process a 50-acre project with an airborne scanner? 1 day, 3 days, 5 days, 10 days, or 30 days? Over half of you think it takes about a day, and then it quickly tapers off after that. Excellent. So that leads me to our second question. How long do you think it'll take from start to finish to set, collect, and process a 50-acre project site with a terrestrial scanner? Same options apply: 1 day, 3 days, 5 days, 10 days, or 30 days. So in this case, for a terrestrial scanner, it's a complete opposite, looking an average of 5 to 10 days for this project site. So pretty interesting between the two methodologies. So today, it is my pleasure to introduce both Mr. Doug Mackey, Survey Manager, and Mr. Tyler Clowes, the Unmanned Systems Engineering Manager for Hoopaugh Grading Company. Together, they'll be discussing from beginning to end Hoopaugh Grading Company's approach to terrestrial and UAV LiDAR in construction. Now, before they start, please take a note at the bottom of your screen that there is a question box, and I would encourage you to add your questions throughout the presentation, and Doug and Tyler will do their best to answer them at the end. So with that said, please help me welcome Doug and Tyler.
Thank you, My-Linh, for having us on. Hello, my name is Tyler Clowes, and good afternoon, everyone, and thank you for taking time out of your busy days to tune in and listen to our approach at Hoopaugh Grading Company and how to use LiDAR daily in the construction, surveying, and engineering field.
Hi, my name is Doug Mackey, and I'm the Survey and Technology Manager here at Hoopaugh Grading. I attended York Technical College for Civil Engineering and Central Piedmont Community College for Survey and Technology. In 2000, I received my PLS in North Carolina, and shortly after, in 2001, I received my South Carolina license. On a daily basis, I oversee and coordinate the tasks inside of the Survey and Technology Department, ranging from getting field crews ready and out the door to finalizing as-built and topos in order to complete our projects. I have been doing this for HGC for 15 years now and been in the surveying field for over 26 years.
Hello again, my name is Tyler Clowes, and I am the Unmanned Systems Engineering Manager here at Hoopaugh. I graduated from North Carolina State University in 2018 in mechanical engineering, and I am currently enrolled at the University of Maine for Survey Engineering Technologies. Here at Hoopaugh, I oversee the day-to-day tasks for setup, collection, and processing of necessary unmanned teams data. I currently have 4 teams that collect and turn out between 500 to 1,000 acres of mapped land weekly. I have been with HGC for 3 years now, working to build the Carolinas.
HGC is a site development company that was established by Danny Hoopaugh in 1953. We currently have 720 plus or minus employees, and we plan to continue growing. We do what it takes is our most important core value, and our mission statement is to be the best. This has led Hoopaugh being voted by its employees as one of the best workplaces to work in Charlotte for the last 3 years. We pride ourselves in being a teaching company. This approach has furthered our success and allowed us to explore technology avenues to stay ahead of our competition. I was brought on board in 2007 with the opportunity to start and be the sole member in the Survey and Technology Department. This has since grown to 7 survey field crews, 5 CAD technicians, and 1 GPS specialist. In 2016, we saw a need to save time, increase accuracy, and expand our capabilities to better track the volumetrics on our sites using unmanned systems. Today, we have 4 unmanned crews, 3 that are aerial and 1 terrestrial, and they operate daily on our sites to keep up with the needs of our project teams and clients. The expansion of the department, these teams, continued until 2019 when we saw the need to be able to set grade of a job site before clearing had begun or even a contract had been signed. As a site contractor, we are paid by the number of total yards we move on a project. Combine this with the Hoopaugh guarantee to our client of a balanced site, and this potential loss of profit was great enough on our sites that we needed a solution. We had heard that LiDAR's reputation to see through the vegetation, so we started exploring this as a solution. We did have some essential criteria the LiDAR must meet in order for it to be a viable option, though. It had to have a similar accuracy to our S7 and S9 total stations or our 986 GPS rovers. RIEGL VZ400I and VUX1LR meet these expectations, and we continue to have success with these scanners in the field.
As Doug mentioned, we've had a lot of success with these scanners in the field. They have given us the ability to collect ground surfaces through multiple vegetation types reliably. And while our accuracies through dense vegetation can vary, we still see accuracies that are acceptable in comparison to the provided existing. This verification of the provided existing conditions across the site on multiple surface types, including concrete, dirt, grass, allows us to verify that we meet or beat this minimum accuracy required. A typical provided existing is on 1/2 foot contours, which results in a guarantee of an accuracy of about 1/4 foot. With this criteria met, it allows us to have grade verification before site critical moments such as building pad installations, roadway pavings, concrete pours, pad walks, outlet control structure installs, the list goes on. When we have these site critical moments, the data is typically in an area of high activity. And because of this, the need to collect the data and provide the results quickly is a high priority to keep a job going. When needed, these scanners have provided us the ability to stamp and submit for final verification on design, as the accuracies needed to meet up to a Class 2A horizontal and Class A vertical are possible. I'd like to take some time now for us to answer a quick poll.
How many acres do you find acceptable to cover in a single unmanned flight? 1 to 10, 11 to 25, 26 to 50, 51 to 100, or even over 100. So we have a pretty even distribution here. Seems to be an average of 25 to 50, but even more, I would say, power users that are aiming for over 100.
Yeah, that's quite the spread there. Here at Hoopaugh, and thank you guys again for taking the time to answer that poll. Here at Hoopaugh, we're in that 26 to 50 range. In the image you guys see below, there's an example of our unmanned system in the field. You can see a static base in the background in close proximity for the highest precision possible throughout the collection process. The wooded area past the power lines was the point of interest in these missions, and the penetration through this dense canopy was accurate enough to start the site on the correct grade from the start of clearing. This has saved our dirt crews unnecessary rework due to a grade bust in the provided initial existing conditions time and time again. When this kind of information is unavailable, it is common to have a significant grade change halfway or more through a project. This presents some serious challenges for tying out to existing utilities or even just getting the site to flow properly by itself. In these two images, you see examples in the flexibility of using the terrestrial scanner in very different ways to ultimately achieve our end goal. When highest accuracy possible is needed on concentrated areas, a tripod-based terrestrial system is a great solution. We use this in pond as-builts and roadway as-builts all the time. The point density from a system like this, combined with softwares like TBC or TopoDot, allows us to easily create line work on critical components like the edge of pavement, back of curb, or even manholes. When we are unable to fly an unmanned system, we have a side-by-side setup like you see that allows us to quickly cover large areas by elevating the terrestrial scanner. The ability to collect without the scanner being level or set up on a known point allows this kind of side-by-side setup to be highly usable and reliable in the field.
This technology's ability to collect existing conditions for commercial and residential sites is a major time and money saver. A field crew would cost $200 an acre to collect the data on a 50-foot grid, resulting in a $20,000 cost for a 100-acre site. With an unmanned system, this cost could be cut to $6,500, and the turnaround time is improved from 5 to 7 days to 1 to 3 days with the same or an increase in accuracy. This quick turnaround means more sites can have this data collected, and we can provide more volumetric estimates to allow the project management team at HGC to make critical decisions on grade or whether to accept a project from the beginning. We retain this information and use it to provide proof of a busted provided existing conditions or issue a change order to continue our work and meet the desired design of our client. These conditions vary greatly depending on the project, but in the Carolinas, we always see a mixture of vegetation and adjoining road surfaces. These scans provide valuable information for these tie points at the road and prove as evidence of the condition on a site was left in post-Hoopaugh's work being completed. This can save HGC a considerable amount of money from rework or delays. We often collect in high interest for future development, such as road intersections, widens, or just any time the conditions in the area may have been altered since we last recorded.
The existing conditions data is taken and compared to the provided existing conditions from the client. I then produce a cut fill sheet to visually and numerically represent the variation between these surfaces. We then take the new HGC existing conditions and run it versus the design, erosion control ponds plan, or a staged combination of both to show the progression of the site and how the change to the site in the existing will affect HGC's bottom line. When the result of these variations has a large effect on the quantity of material HGC will need to move to meet the final design, typically a change order with the client is started to continue work. This early information is used by our teams outside of Hoopaugh and has even led to a project temporarily going on hold by the client while the site was re-engineered to work with the extra material and make it more cost effective. This resulted in a better outcome on the project for all parties involved. I'd like to take another second here and do another poll question.
Thanks, Tyler. How many average blind check shots or ground shots do you take on a 50-acre project? 0, 1 to 25, 26 to 50, 51 to 75, or 76 to over 100? And it looks to be a majority average of 1 to 25, and some a little bit more than that, up to 50. So pretty interesting distribution, but that makes sense to me.
Yeah. So at Hoopaugh, we do that 50 to 75, 50 to 100 range for a site that size. That just gives us some shots that we're able to toss out if we don't necessarily have them in a good position. So no matter the size or scope of a project, our overall workflow for how to compute this information and feed it to our teams is the same. The client's going to provide us with a rough or final plan set from the engineering design firm. We take this model and convert it to function with our grade control systems. Site control is then set off of the provided benchmarks and boundary information. One of our LiDAR crews will go out to collect the initial existing conditions. That data is processed, and those surfaces are compared in AgTech. The site is typically actively cleared by field crews, and we rinse and repeat steps 4 through 6 to recollect and reconfirm our initial conditions and set final grade on the site. This cycle continues for us until the completion of a project. We fly sites 10 to 20 times until the completion of the project. As I mentioned with the volumetric information, we collect on our sites continually. We use these scanners to collect these progress checks for multiple reasons. These areas could be roadways, stockpiles, or just small busy sites. With the ability to collect data in these areas where visibility can vary by the second, we can safely get the needed information with little to no intrusion to site work or passing traffic. The site in the image you see had vegetation varying from bare dirt all the way to chest-high erosion control veg. And this had been there for about 2 years. The owners were required to annually collect information to show the erosion control measures were working properly and that there were no areas of rework needed to protect the environment and continue work. Sites like this typically have a large amount of passing traffic on roadways or parked equipment and machinery on the site. And a lot of times we see large transmission towers that block a clear line of sight to the ground, but all of these are easily classified out from the needed information using TBC or TopoDot or similar softwares. This site is a great example of how a site can be left for a large amount of time, and the ability to show the need for rework due to the elements and their effect on the site has allowed HGC to stay profitable throughout the completion of this project. These types of collections are typically needed to be collected and turned around within a very short time frame to avoid fines or delays later in the project, and LiDAR has definitely assisted with that. This site is an example of how, using a walked collection method, we were able to collect in a flight restricted area with a very high shot density quickly. We walked this to reduce the equipment risk as multiple trades were on site completing work, and even driving past them with the side-by-side in some of these areas was impossible to do safely. This was a 40-acre site, and a one-man team with a scanner was still able to collect the needed information within a day and turn the data out to the project team the following day.
When a site is suitable or we're trying to cover a large amount of area quickly, we can expedite this process by mounting the scanner to a side-by-side. This allows us to stretch the distances between the scan positions as well as reduce strain on the technicians doing collection. While the accuracy may drop by increasing these distances, we are able to provide monthly process checks. This kind of month-to-month check allows confirmation of grades before building pads are locked in. This allows us to cover up approximately 100 acres in a day. We provide these progress checks on our residential projects as well as using the scanners. We are able to meet a few goals at the same time. We oftentimes have areas that aren't completely cleared of vegetation. This is typically a result of trying to reduce the amount of bare earth on the site we have at any moment. In certain counties, we may only be allowed to clear it with 20 acres at a time. These areas are not typically perfect shapes or portions of the overall site, but more of a clear space as we need material available to continue work. The ability to still collect information on these areas adds to the accuracy of our volumetrics. If a noticeable difference between the provided and our collected existing conditions is present, and the site has already begun to be cleared, a second collection without vegetation will be used to confirm the new surface. As houses start to get built, the ability to collect the information between these houses decreases. Using LiDAR, we are able to fly, collect in fashions that result in a large amount of accurate data and keep the site updated. This ability to collect in these problem areas results in the ability to record their completion as we go, not just the conclusion of the site.
When we collect as-built information on our commercial sites, we face a combination of multiple urban vegetations such as ornamental bushes, trees, and even flower beds that make an unobstructed view of the structure or bottom of the structure nearly impossible. These areas differ greatly from our erosion control vegetation, but similarly to them, we can easily collect in these areas with little to no disruption of the site, and we still get the information we need. This contour map is showing an active Amazon shipping facility that we collected during normal business hours. The horizontal relief between the trailers and the vertical relief between them and the ground was very small. However, by finding a line just far enough from the trailers and out of the way of the moving trucks, we were able to safely and effectively see the bottom edge of the building and the edges of the loading docks, where we were able to collect elevations between the trailers without a single truck ever being held up or moved. We use these scanners' abilities to collect in GPS-denied environments like underground retention ponds, insides of structures, and in Indian orientation to our advantage. In this example, I was able to collect this as-built information with metal rafters actively being hung and little to no GPS signal inside of the structure due to interference. At HGC, we have gotten to where we are by testing these scanners in the field and trying new applications whenever possible. Our field technicians collect and process their own data, and it is our belief that this has allowed us to take large leaps in our success by seeing how actions in the field can affect the data later in the office. Thank you all for your kind attention. And I have one more poll question. I really am curious to see what everybody's opinion is on it.
What is the average vertical or horizontal error that is acceptable for your application? And pretty overwhelming response there, Tyler.
That is right on par with where we are. Just for everybody's reference, we're in that 0 to 0.1 category as well for all of our submitted topos. Sometimes it creeps a little above that, but that's just for internals.
So now we're going to hand it over to some Q&A. We've got quite a few questions that have popped in throughout the presentation. Thanks so much, everyone. We'll start the stage with Doug. Can you clarify what a check shot or a ground shot is for those that are not versed in surveying?
It's just a topo shot of the existing conditions. We use it based on our vertical datum to make sure it's the same as we get with our LiDAR scanners. So it's just a topo shot we use to verify.
Excellent. A follow-up to that is for those check shots, are you taking 5-second RTK shots, or are those 2 times 1.5 minute observations that are averaged together?
Yeah, just usually 5-second RTK shots on that.
Tyler, do you normally need an FAA Part 1 of 7 waiver for beyond visual line of sight to cover your acreage over a forest?
That's a great question. No, we have figured out in our area how to avoid going BV loss. We recently brought on some additional pilots for this exact reason. We typically send 2 to 3 men out with one of these teams when they're going to be doing their flights, and we will kind of surround the site, honestly, and we'll just make sure we all are able to see it. We have clear communication with the pilot, and we typically have a VO and a pilot standing side by side if possible.
Another question is regarding operations. If you're flying over active construction sites, how are you handling the FAA requirement to not fly over unprotected people or moving vehicles?
With all of these people being internal to Hoopaugh, they're all technically a part of our operation. We have all of our employees aware of the operations going on when we step on site, and we all have radio communication when we're on site with each other.
That is definitely something to distinguish and clarify, so that's good. Let's go to some data questions. What are you using for control to calibrate the data captured from your LiDAR?
Depending on the system, we kind of switch up our control setups. So we have some targets that we have made that are 2 foot by 2 foot reflective targets that we will place on the ground. We typically have a survey nail that is placed in the middle of these targets. We'll take a shot on that for anywhere from 1 minute if we're using RTK to up to 5 minutes on a VRS connection until we meet our desired accuracies for the survey control. From there, we will tie that down just in right precision like normal. But using a terrestrial scanner, we have the 100mm reflectors that we use. They've worked really well for our application. We're able to see them from 300 to 400 feet away easily with the scanner and get a good shot on them.
And Tyler, about how many control points would you use on a 50-acre site?
So on an unmanned system flight, we would have at least 5, anywhere from 5 to 10, depending on the point density that we're looking for. We're strong proponents of putting control at the either ends of your flight lines, and specifically 4 corners of your mission if possible. It just makes tying that control down a lot cleaner and allows the missions to kind of mesh together a little bit cleaner in our opinion. But when we go to a terrestrial setup, we would definitely be looking more in the 10 to 15 range for targets there.
So it definitely depends on your acquisition method.
Yeah, for sure.
So since I'm a little biased, as UAVs is my world, can you talk a bit about the different platforms that you've used so far, and talk about your experience from upgrading from your mini VUX-1 UAV system to now operating a VUX-1 LR-22 system?
Yeah. So like you said, we started off with a pretty straightforward setup. We had a M600, a DJI M600 with a mini VUX-1 underneath it. We were getting very good results from that, same accuracies that we see now. It was just very time consuming to fly, and it took us a lot of missions to get the kind of density we were looking for. So we ended up, when we had to upgrade aircraft, we went to BFD Systems, and since then we've stuck with them, and they have since transitioned to become free fly systems. So now we are flying an Alta X with the VUX-1 LR, like you mentioned, and both of those systems have been fantastic. The aircraft has very good battery life and very good flight times for what we're looking for. And the scanner itself has allowed us to fly at speeds which we can cover a lot of ground, but still keep our point density high enough that softwares like TopoDot or TVC don't have a very hard time classifying out for features. But overall, the upgrade from a mini VUX to a VUX-1 has been a good one for us for sure. It came with its learning curve, but it's been a definite good upgrade.
Excellent. I love hearing that. What kind of point density are you generally trying to achieve per your project spec?
It really varies. On a open site out in doing just volumetrics, we're looking anywhere from 150 to 250 shots per square meter. But when we start trying to get into doing as-built and stuff like that, we've stepped it up as high as 800 to 1,000 points per square meter. When you start getting that high, the computers start to not like you so much. So we have to kind of balance that.
How do you plan for or address potential voids in the data captured from line of sight or your equipment limitations?
So we fly in an orientation of crosshatch typically. That has just come from experiences out in the field. When you're trying to penetrate vegetation, there's a bunch of different strategies out there, but our strategy is let's punch through all those gaps. Let's see through all the holes. So we fly at an altitude that our angle of incidence to the trees varies depending on what the angle from the scanner is. And when we change our direction of flight and we vary the flight lines that much, you inevitably have the best chance of getting through. When we don't get through in those areas, we have sent out our same crews that have collected the unmanned data, and they have walked it, or they have combined this data with a terrestrial scan to kind of fill in those void areas where you might not be able to see it with an unmanned system.
Okay, last question for today's session, just to close it out, is what kind of air time, flight time, are you achieving with the VUX-1 LR system on your aircraft?
16 minutes. So in 16 minutes, we're covering about anywhere from 30 to 40 acres, depending on the day. So about 16 minutes, and like I said, we're happy with that. It's a shorter flight time than some of the aircraft promise, but it kept us within the weight limitations of the FAA, which was a big plus side for us. It allowed us to have that flight over people as long as they're part of our op without it being as much of a hazard, without exceeding that weight limit, and we are still covering a significant amount of ground.
Okay, I did say last question, but follow-up question is that 16 minutes is related to the VUX-1 LR system scanner plus the Planix APX20 IMU and a Sony A7R 3 cameras, so it's pretty well outfitted.
Oh yeah.
And with
Yeah.
that payload weight, how fast are you flying?
It kind of depends on our day, but it does vary from 3 meters a second. I mean, heck, we've gone 2 meters a second, all the way up to 10 meters a second, 11 meters a second. It really just depends on the application. Same thing with the flight line spacing. We kind of have gotten to the point where we can look at a site and know how we're going to have to fly to be able to penetrate that canopy. And that's just come from experience out in the field and doing it on a lot of different sites, and doing it on a lot of different canopies that have similarities but differences.
So I didn't realize you're also flying as low as 2 or 3 meters per second, even with this LR system. So I think I'm understanding the 16 minutes now.
Yeah, for sure. So we stretched out our line spacing a little bit when we got the LR, and I say a little bit, I mean, we stretched our line spacing out by 3 times what we were with a mini Lux. But we do still map between that 3 to 5 meters per second mark, just because the scanner is so stable, especially on that Alta X. It's just so stable in the air. You can see it. It looks like it's just sitting on a table. So the data has been rock solid, and if it ain't broke, don't fix it, is what I've always been told. So we're covering 40 acres a mission with it, and we're able to keep up with our needs. So we're very happy.
That's excellent. One final question. How high are you flying at such speeds?
Again, that varies just depending on what we fly in Class B airspace, so a lot. So we're in the Charlotte area, and we will fly as low as 80, 90 feet if we have to, but that comes with its risks of you have to watch wood lines, and you have to stay you have to be very vigilant of not clipping any kind of tall obstructions, or if we have a stockpile that happens to be particularly tall that day. But all that being said, we fly all the way up to 300 feet. We don't see the need to go over 300 feet. When you start going up in altitude, the decrease that you see in the accuracy, in my opinion, and the spread that you see in the shots, it just isn't worth it to us. So, like I said, we're trying to poke through all those little holes in the vegetation. So as close as we can be to those holes, we're going to have the least amount of beam separation, and we're going to have the best chance of having the most different angles when we get to the vegetation. If we were at 400 feet above it, our angle of incidence would be very similar within our entire swath, versus if we're at 250 foot above a 200-foot vegetation. So
that's excellent news. Okay, I think that's all the time we have for today. We have gone over our allotted presentation block. Thank you again so much, Tyler and Doug, for joining us and sharing your experience using both the RIEGL TLS and ULS systems and how critical they are to your operations. If you have any additional questions, which I see some of them still popping through, which is great, please feel free to contact Doug and Tyler or myself directly, which my email is not listed, but that's okay. And stay tuned for next month's webinar series schedule. Once that's available, you'll find the registration links on the RIEGL newsroom, as well as our LinkedIn, our social media pages, and feel free to contact me directly. With that, I want to close it out, and thanks again for joining us. Have a great rest of your day.